Hello everyone, so today we're going to talk about opportunity cost and the production possibility frontier, which is also known as PPF. In the last class, you've covered the concepts of opportunity cost as well as scarcity, which are very important concepts in economics. Today, we're going to continue talking about opportunity cost, but we're going to do that in further details. We're going to learn how to calculate opportunity cost as well as covering the production possibility frontier, which is basically a graph that represents a lot of the important concepts in economics. So these are the things that we're going to cover throughout the lesson: production possibility frontier, or as we said, the PPF, and its relation to the opportunity cost. We're going to calculate opportunity cost, and we're going to talk about fixed versus changing opportunity cost, and so on. Right? We're going to talk about factors of production, where should we produce, economic growth. Now, for the calculating part of opportunity cost, you want to have a paper and a pen beside you to practice, as well as a calculator probably. All right, so the slide starts with introducing the production possibility frontier, which is this graph that I told you about earlier, right? So the graph is basically a representation between two products. We have product A and product B, and it basically represents a trade-off between producing any given two products, right? So let's say you've got milk and wheat, any two products that you can think of. When we draw the production possibilities or the different production possibilities that we have for those two products, we're going to get this graph, right, which is called the PPF, or the production possibility frontier. Right, so it's a curve that shows you the maximum possible combination of two products that may be produced within the available resources and the current technology. Now, this part here is very, very important, all right? Which is basically ceteris paribus that you guys covered in the last class, right? So meaning all things being equal. So currently, given the current amount of resources, let's say we have in Bahrain, and the current technology that we have, we can produce that much of product A and that much of product B, all right? So we can produce this much product A or this and that much product B, or this much product A and that much product B, or be here at point C and produce somewhere here at the graph, all right, or anywhere at the line. All right. Right, so in point A, I'm producing more of product A and lower amount of product B. When I go to point B here, I'm producing less of product A and more of product B, and so on, right? Right, so anywhere on the line or inside the line are your production possibilities, or the different possibilities that you can produce of these two products, which we're going to cover in further details in the next slide. Right. So this production possibility frontier can be valid for a whole country and can be valid for you yourself as well as an individual. Right, so individuals or countries have their own PPFs. Right. Now, any economy will have to choose where do they want to produce on that line. All right, do they want to produce in point A in that line, or point B on that line, or point C, or somewhere in between, and so on. Right. So it's basically choices that the country or you as an individual need to do. Do you want to produce at point A or point B or point C, and so on. Right, and as I told you earlier, anything on the line or inside the line are all your production possibilities, different possibilities that you can produce. Right. Now, all the points that are outside the curve, so let's say we have here point Y, that is outside the curve, above the line, this is basically, we call it unattainable or undoable, all right? So we cannot produce beyond this line. This line is, as I said earlier, is my maximum capability. Point X is doable, or what we call attainable, all right? But it's not efficient, all right? So if we are in the line, then it's attainable and efficient. If we are inside the line, then it's attainable but not efficient. And if we are point Y here, then it's basically unattainable, or attainable is basically another word for doable. So it's undoable. Right. So here they're telling us how is the relationship, or what is the relationship between PPF and the opportunity cost. Now, if I am on the line, if we are at here at point A or B or C, which is, we said, attainable and efficient, then I'm using all of my resources, right? And I'm using all of my resources efficiently, right? So if I'm using absolutely all of my resources efficiently, then I'm going to produce somewhere at the line. And I can only produce more of one good. So I can only produce, if I want to produce, for example, more of product B, if I want to go in this direction and produce more of product B, I will have to produce less of product A, right? This is the only way forward if we are somewhere here on this line, right? Right. So that is why the PPF is related to the concept of opportunity cost. It's actually represent the concept of opportunity cost. All right, so we said opportunity cost in the last class is what you have to give up, all right, because you've chosen something else. So because I've chose to go to work, for example, I gave up on watching Netflix, right? And this is the best alternative that I have given up. This is the best thing that I would have done if I went to work, all right? So the same thing applies here. Because I want to produce more of product B, I have to give up product A. So product A is the opportunity cost, or the thing that I'm giving up, right? So they're telling you here, if you're on the line, the only way you can produce more of one good is if you produce less of the other good. Right. Then here they're talking about the concept of trade-offs. As you know, in the last class, this is a very closely related concept to the opportunity cost, that I have to give up one thing to get another thing. Right. Now, PPF, as you've seen, it looks usually as the previous graph that we looked at, which is a curved or a bowed curve. Here, you have a straight line PPF. So PPF can be a straight line PPF or a bowed out curve. All right, the most typical type of PPF is the one that we've seen in the previous slides. Straight type or straight line PPF is not very common. All right, it is, let's say, a simple special type of PPF. So we're going to learn when does the PPF look the usual shape that it looks like, and when does it look like a straight line graph. Right, so here we start with an example that is an individual PPF of yourself, let's say, and you are looking at your production possibilities of cakes and of baklawas. Right, so given your talents, given the amount of resources and time that you have, this is your production possibilities of baklawas. If you produce 5 cakes, you can produce 5 cakes and 0 baklawas because you're here at the line, right? Which is what this is telling me. We're at point A here, where at point A I can produce 5 cakes and nothing of baklawas, all right? So that is here. Or on the other extreme, you can produce 10 baklawas, which is here, and 0 cakes, all right? So that's why, again, you are in this line. Or you can produce here, point B, somewhere in between, right? So this point B, represent 2.5 cakes and 5 baklawas, right? Now, it's very hard for me to write with the mouse, but I'm trying my best here, right? All right, so this is the PPF drawn out, all right? So you can have in the exam, you're gonna have either PPF that looks like a graph or a PPF that's given in a table format, all right? And you would be asked to calculate the opportunity cost, right? So you should know how to deal or read with both of these. All right, so in this slide, we're gonna calculate the opportunity cost. And here you might want to have a picture of the previous slides beside you so that you know what we're doing. So you can have the table beside you there in a separate device like your phone to look at the numbers, right? So the question here is to calculate the opportunity cost of producing a cake, right? And what you're gonna do is basically you're gonna follow this formula, right? So the formula says that the OC of A, which is the opportunity cost basically of A, is equivalent to the change. This is supposed to be a triangle, by the way. So this is the change in B over the change in A. Right, so it's very hard for me to draw things using the mouse because I write with my left hand and I use the mouse with my right hand. So things get very, very difficult, let alone that this is a mouse. All right, so excuse my handwriting, but just try to bear with me because I'm really doing my best here. All right, so OC of A is the change in B over the change in A, and the answer is gonna be in B. All right, so basically the opportunity cost of product A is the change of product B over the change in product A, and the answer is going to be X units of product B. So if we can apply this to the opportunity cost of cake, so cake is our A here, then that means that B is our other product, which is the baklawas. Right, so I'm going to write just BAK for the B because as you can see, it's very hard for me to write, right? And over the change again in cake, because that is, as we said, our product A, and the answer is going to be a certain number of BAK again, which is baklawas. Right, now to get the change, what we mean by the change is that usually in the exam, we're gonna tell you calculate the opportunity cost between point A and B. All right. So you're gonna go to the table and you're gonna look at the points. We have point A, B, and C. Now, for this type of question, if the opportunity cost was straight line PPF, then we don't need to tell you what are the 2 points that you need to look at, all right? Any 2 consecutive points that you're gonna choose are gonna give you the same PPF. So whether you calculate between point A and point B or point B and point C, it's going to be the same answer, and that's why only in a straight line PPF we're not going to specify the points. Right? You're going to learn why later on. All right, so if we can apply that, let's say I'm calculating the opportunity cost between point B and point A. All right, from the graph. So I want the OC of cake again. Oh God, OC of cake, and the OC of cake is gonna equal to the change. Let me see if I can use this actually to write. Not really. All right. Anyway, so is the change in product B with the change in the number of baklawas between point A and point B. All right. So you're always gonna take, so I have in point A, I had 0 baklawas, in point B, I have 5 baklawas. What you're gonna do is you're always gonna take the bigger number minus the smaller number, all right? Regardless if point A was 0 and point B was 5, you don't say 0 minus 5, you say 5 minus 0. So always here, you take the bigger number minus the smaller number, all right? So this is OC of cake between point A and point B. Right, so this is 5 minus 0 is the change basically in B, baklawas. And I'm going to divide that by the change in number of cakes. So if you go to the table again, you're going to see that in point A you had been producing 5 cakes, in point B you're producing 2.5 cakes. So again, bigger minus smaller, it doesn't matter which point is first, so 5 minus 2.5. Right, so this is basically the change in A or the change in cakes. Oh. Right, and you calculate that, so that is 5 over 2.5, right, which is basically 2. Now, when I say 2 to what? To baklawas. Alright, so this is what I meant there by the formula. There's another formula that can be useful to you, which is going to help you to find the answer of the second question here. So the other formula is if I know OC of A between point A and point B, so if I know OC of cake, for example here between point A and point B, then OC of baklawa, اللي هو OC of B, right, baklawa, which is the OC of B between point A and point B, is basically going to be 1 over the OC of cake. Right? So in the second question, where they're asking you for the opportunity cost producing 1 baklawa, you're going to see OC of baklawa is 1 over 2, right? Which is going to give you half, but that half, the units now is going to change. So I want OC of baklawa, the answer is going to be on the other product, so you're going to say it's half a cake. Another way you can do this is by following that main formula there, right? So you're going to take now, if you want to do the whole formula, you're going to take the change in cake over the change in, let me see there. So you're going to take the change in cake, oops, all right. You're going to take the change in cake over the change in baklawas, and that is how you're going to get your answers. So here, let me delete things. Right, so here, if you want the OC of baklawas, B, you're going to say it is the change in A, which is cake, over the change in B, and the answer is going to be in A. Right, so OC of baklawas is going to be in cake and so on. All right, so I hope that is clear for you despite the handwriting. So that's basically what they have done there, right? That Fatma needs to give up half a cake to produce 1 baklawa. So we're moving on to a different concept here, which is basically the idea of fixed versus changing opportunity cost. So earlier in this class, I've talked about opportunity cost that can be, that looks like a straight line curve, right? Or a straight line basically, which is this, or a bowed out curve, which is this, right? And we said the most common type of PPF is the one that is bowed out. Right, now when do we have a straight line curve and when do we have a bowed out curve? We have a straight line curve, all right, when the opportunity cost is constant. So when the opportunity cost is fixed or not changing, we're going to have this straight line curve like you've seen in your baklawa and cake example. And that's why I said it doesn't matter which 2 points you've chosen, you're always going to get the same answer. So to reiterate, if I have here point A, and I have here point B and point C, then if I calculate the opportunity cost between A and B, is going to be the same as the opportunity cost between B and C. So I say this was 3, and this is going to be 3 as well. While on the other hand, if I have the bowed out curve, then the opportunity cost that I'm going to calculate is not going to be equivalent. So again, I have point A here, I have point B here, and I have C here. So if you had a bowed out curve, we need to tell you which 2 points do we want you to calculate the opportunity cost in between. So if you calculate the opportunity cost between A and B, let's say, is going to be a different number than the opportunity cost between point B and point C. And you're always going to find that the opportunity cost between A and B is going to be a central number, let's say certain number, sorry, let's say 4. But when I go to point B to point C, the opportunity cost will be increasing always. All right, so this is 4, let's say this is 5. And the idea here in the bowed out curve, I have a changing opportunity cost, and in particular, I will have an increasing opportunity cost. All right. Now, the other thing that you want to know is why do we have a curved PPF? Right. Now, a straight line PPF, we're going to have it, which is, as we said, a fixed opportunity cost when the resources are efficient in producing both products. So in your example, you had a cake and baklava, and the time or the resource that you are looking at there is the same resource, which is time, right? So when you have the same resource, it's going to be equally efficient in producing both products, then the PPF is going to be a straight line. However, when you have a a changing opportunity cost, a bowed out opportunity cost, then that means that the opportunity cost is going to be increasing. And that applies to most life scenarios, all right? Because I have two resources that are not equally efficient in producing both products. So for example, here you have computers and you have wheat. And the resources I need to produce computers are different than the resources I need to produce wheat. So as I go from A to B, I'm producing more computers here, right? And less wheat, right? So what I'm going to do is to produce more computers, if I'm on the line, I have to pull someone from the wheat industry or a farmer to tell him go and produce computer, because we said if we are in the line, then I'm using all of my resources. I'm using everyone that I have in the country. Everyone who wants to work, he's already working. So the only way I can produce more computers is by pulling farmers from the wheat industry. Now, is he going to be efficient in producing computers? At the beginning, I'm going to try to pull the farmers that are the best people or have the best technological skills, right? As much as I can. But as I go in this direction from point B to point C and produce more and more computers and less wheat, then I'm not going to find people that are going to be very good at producing computers. And actually what I'm doing is I'm pulling people off the wheat industry, which is the best thing that they know, and putting them in the computer industry, which is basically, as I go there further below, I'm going to pull people with very, very low technological skills, and I will have to pull the best people in producing wheat as well. So that's why the opportunity cost, the number of wheat I have to give up to produce more computers, is going to increase as I chose to produce more and more computers, right? And now we're just talking about the points that are on those lines. We're not talking about the points that are inside the curve or outside the curve. All right, so this is illustrating the point that I was trying to tell you there for computers and wheat by giving you different examples of coconuts and fish. Right, so again, you have a trade-off between gathering coconuts and catching some fish. All right, so they're telling you here at first, to produce 20 more fish, you only had to give up 5 coconuts. So from this point, right here, whatever that point, let's say point X to point A, you were able to produce 20 more fish, but only 5, which is 30 minus 25, less coconuts. But as you go here from point A to this point here, let's say point Y, you were able to produce again additional 20 fish, but you had to give up much more coconut, all that amount of coconut there, which is basically 25 minus 0, which is 25 coconuts. Right, so the opportunity cost has increased massively from 5 coconuts to 25 coconuts, because eventually you will have to pull out the people who are very good at producing coconuts or gathering coconuts and very bad at catching fish, and to be able to move into this direction. All right, so here we're going to talk about, again, the straight line PPF, and we have a couple of questions there. So the first question is, what is the scarce resource when we're choosing between work and leisure, right? So the resource here that I am looking at while I'm studying or deciding how many hours of leisure should I have is basically time. Right? Since it's the same resource, it's equally going to be efficient in producing both because the resource is the same. And I'm going to have a straight line PPF, so between point A and B is going to be the same between point B and C, and so on. Right? Right, so this is what I just mentioned, that time is a resource that is equally suited to studying or leisure. So the exchange between studying and leisure, for example, I want to go in this direction, all right, and study less and have more hours of leisure, then that's gonna have, the OC is gonna be at a constant rate. Right. And here is just reiterating again about the increasing opportunity cost, which is in the bowed PPF there. Right, so we said our resources, which could be land or labor or capital, they're not equally suitable or adaptable for the production of all goods. So my resources are going to be better in producing one good rather than our goods, and so on. Right, so let's say that a country is trying to decide between producing rice and steel. At the beginning, they will probably give up land for producing rice easily because we have lots of land. So at the beginning, when I want to produce less land and more rice, it's going to be easy. But as I said, as I go on and on and on, I will have to give up very good land to produce and take people that are very bad in producing rice. So that's why my opportunity cost is going to keep increasing, right? Which is again just another example of what I explained earlier. Right, so here we've got the factors of production, right? And factors of production are basically called also the resources or the production inputs. And these are basically the resources we use to produce goods and services. We have 5 resources there. We have the labor, we have the human capital, they're in no particular order, the entrepreneurship, physical capital, and the natural resources. So labor, when we talk about labor, we're talking about farmers or someone who works in a factory that has a physical and mental effort to produce the product. The human capital, on the other hand, we're talking about the knowledge and the skills of the people that are needed to produce a product. Right? Then we have some natural resources, which are like oil or gas, so the resources that we need to produce goods and services. And then we have physical capital, and in economics, physical capital should be something that will help me to produce something else, like equipment or machines or factories and so on. And then last but not least, we have the entrepreneurship that are going to put those 4 different factors of production together and organize them to help me produce what I need to produce. Right, now you've got an exercise, and what you want to do again is take a picture of on your phone of that exercise, or be able to view it from a certain device so that you can solve the question that is going to come in the next slide. All right, so in this slide, we continue trying to calculate the opportunity cost, but this time using a graph. And this is the PPF between the operations and the number of app. So the question is, calculate the opportunity cost of app. You have to concentrate on which product are they asking about. So in this point here, they're asking you about calculating the opportunity cost of apps. All right. As you move from A to F. And what they mean here, they want the opportunity cost between A and B, and then point B and C, and then C to D, and then D to E, and E to F. So that is what you are going to do, right? Now, the formula that we mentioned earlier, if they ask you to calculate the OC of app, then what you're going to do is you're going to take the change in the other product, which is the change in ops, and you're going to divide that by the change in apps, and the answer is going to be on the other product, which is ops. Right. So if we're doing that from point A to point B, then you're just going to read the numbers off. So the change in ops between A and B, the number of operation was 15 and it got to 14. So all you're going to say is 15 minus 14, which is gonna the biggest number minus the smallest number, no matter what. Right, and we're gonna divide that by the change in the apps, which is basically 4 minus 0 between point A and point B here, 4 and 0. So that's going to be 1 over 4. And the answer is going to be on the other product, which is ops. So you're going to keep doing that exactly between every other point. So from point B to point C, I can see that here the change in the number of ops is from 14 minus 12 over the change in number of apps, which is between 7 and 4. So that's 2 over 3 for the next one, and so on. Right, so you can see there. Alright, so this slide is showing you basically the answer for the opportunity cost between A to B, and then B to C, and then C to D, D to E, and E to F. Now I've done the first two with you. Right, so we said for the first one is going to be 1 over 4, and on the second one is going to be 2 over 3, which is 0.68. Right, so you're going to keep calculating that to find the other answers. Right, so this is another exercise for you to practice on calculating opportunity cost using graphs. So the numbers have changed and the products have changed, but the idea is exactly the same thing. Right, so I recommend, as I said, that you practice this before you watch my next slide. Right, so again, let's see, I'm going to start and calculate the opportunity cost between point B and point C for the track. Right, so this is OC of track between point B and point C. Right, so as I'm going in this direction, then that is the opportunity cost of tracks. Right, because I'm trading off more tracks for basically less cars. Right, so what you're going to do is, we said if I want to calculate the OC of track, so I'm going to just write OC of T here. I'm going to take the change in the other product, which is basically the cars, and you're going to divide that by the change in tracks to find your answers, which is going to be in car. Right. So I'm going to say now the change in cars between those 2 points. So this is point B and this is point C. So the numbers that you want to take are 46 and 39. So you're going to say it is 46 minus 39. And we're going to divide that by the two other numbers here between point B and point C for the track, which is 0.7 and 0.4. Right, so again, if you don't know how to read graphs, please look at the video that is there on Moodle. Right, so again, bigger minus smaller, bigger minus smaller, so that is 3 here and 7 here on the top, and that's going to give us 2.33 if you put that in the calculator. Right, now what matters when you calculate the opportunity cost is that you look at what is the opportunity cost of, so it's the opportunity cost of track, then I need to put the other product on the top and the same product on the bottom. I calculate the change, and then as much as this answer, the numerical answer is important, the unit is what is important. So you can't tell me just 2.33, 2.33 what? So you're going to say if it's the opportunity cost of track, then that means it's 2.33 cars. And how you're going to translate that is to produce one track, we had to give up 2.33 cars between point B and point C. Now, another question that we can ask you is to calculate the opportunity cost the other way around. So from point F to point E, right? So from point F to point E, you are giving up tracks to basically create or produce more cars, right? So that's going to be now the OC of cars. So if you want the OC of cars, what you're going to do there is you're going to take the change in track, which is between those 2 points, 12 and 11, and divide that by the change in cars between those 2 points here, which is 15 and 0, point E and point F. Right, so this is again bigger minus smaller, so this is 15 minus 0. So this is basically OC of cars between point F to point E, because now we're going in the other direction. Right, so that is going to be 1 over 15, and we said the unit is very important, so you have to tell me it's 1 over 15 T or 1 over 15 truck. All right, so here you've got the answer to each point, from point A to point B, B to C, C to D, D to E, and E to F, which are exactly the same that I have done. So you can just go and practice those, please. Right? All right, now another question that you would like to know is where on the curve should we produce? So at the very beginning of the slides, I've talked about different points on the PPF. So I said if we are outside the PPF or beyond the PPF here at point D, then this is called not attainable or not feasible or not doable, basically. All right. So in economics, instead of saying not doable, you're going to say not feasible or not attainable. If you're producing somewhere inside the curve, then it is attainable or feasible, but you're not being efficient. If you're producing on this line, however, on this blue line there, then you are being basically efficient. So it's attainable, it's doable, and it's efficient. All right. So here at point A or here at point B or any point here, let's say this is point X, then this is you being efficient. And you always want to be efficient in economics, so you should always produce somewhere on the line. Beyond the line, basically, we would love to get there, but it's not doable here. And if you're producing anywhere inside the line, whether it's here, point C, or point, let's say this Y, then you're basically wasting your resources. You're not using your resources well, and you're being inefficient. All right. So here's an exercise for you. So I suggest that you pause the slide and you try on this exercise before you hear the answer. So basically they're asking you which of those choices are efficient, which are inefficient, and which are impossible. So here at point F, we said it's impossible, it's unattainable. I would love to go there if I can, but currently, given my current resources and technology, as a country, I cannot reach point F. If something else changes, which we're going to talk about in a bit, then I would be able to reach point F. If I'm here in point D or point E, then it's doable, it's attainable, but I'm being inefficient. Anywhere on the line, whether it's point A or B or C, then I am being efficient. All right, so these are the answers. Right. Now, what could change that would lead me to get into the point that we looked at earlier, which is point F, which is outside the PPF, which was unattainable. Right now, one of those scenarios, or one of the things that would change and would enable me to get to a point that was outside of my PPF, is economic growth. Right? So basically, over time, your economy is going to grow. Bahrain in the 1930s is very different from Bahrain right now. So let's say the first curve here was Bahrain's production possibility over the 1930s. And right now we wrote here point B, or the second PPF, because of the economic development that we are in. Right? So economic development is one reason for the PPF to be shifting outward. All right. If we look at the second graph here, again, there's an outward shift in PPF. So we call that an outward shift. All right. But this outward shift looks different than the outward shift that I showed you earlier, right? The first outward shift, we call that a parallel outward shift, right? Parallel outward shift, and this is basically an in parallel outward shift, right? So if your PPF shifts outward equally across the same, all the same distance across the same point, then this is a parallel shift, which is going to be due to economic growth, right? But we can have another scenario, which is basically not an economic growth, but a technological change that is only going to affect one product. So this is scenario A, which is economic growth, and this is scenario B that will lead me to produce to a point that is outside of PPF, let's say point Y, if I have a technological growth that is only going to affect one product. Now, which product is being affected here? Automobile. So if I discovered a new product that's going to enable me to produce more automobiles, then I'm going to have an unparalleled shift because my tanks are not going to be affected by this device that is enabling me to produce more automobiles, but my automobiles are being affected. Well, if you have an economic growth on scenario A, you would probably have a parallel shift, right? So just again, notice if it's technological shift, which product is it affecting, and it's going to cause an unparallel shift because it's going to affect most likely one product and not the other. And the products that it's going to affect, you're going to see it's the product that is going to increase. While the tanks here didn't increase in both the this line and this line, but the automobiles have increased from 500 to 800. Right, so here they're defining the economic growth, which is basically the economy, the ability of the economy to produce increasing quantities of goods and services. Right, so I grew now, I can produce more goods and services basically than before. And here they're talking about the idea of parallel shift in the PPF. All right, and we said we call this outward parallel shift, and both goods will increase equally. Right, so this is the outward shift. Now I can have, instead of a parallel outward shift, I can have a parallel inward shift. So the shift, the PPF is going to shift inward parallelly, so inward in this direction, and I'm going to have this new PPF here. Right, again, excuse my drawing skills there. Let me try to clear that out and draw one again. Right, so this is a parallel inward shift. Now reasons would be for that could be war or a natural disaster like a volcano and a hurricane and so on. Right, so you can have a natural outward shift to point B, which is due to economic development and or economic growth. Then you can have an inward shift in point A due to war or natural disaster like a volcano or hurricane or something. So this is an example of another unparalleled shift that could happen, that we could be able to reach a point that is outside of our PPF. So this is our first PPF there, and this is our second PPF that we reach, or point B that was previously outside of our PPF. Now this slightly looks different than the unparalleled shift that I've showed you earlier, because here the increase is in the other good, which is the capital good. Right, so capital good, an example of that is, for example, something that's going to help me to produce cars, and I have consumer good, an example of that is wheat or rice or something that's going to be used for consumption, while this is something that's going to help me produce a long-term assets basically. All right, so if there's something that's only going to affect my ability to produce basically automobiles, for example, then I'm going to have an unparalleled shift that looks like this. So the consumer good is not going to be affected, the rice or wheat is not going to be affected by the device that's helping me to produce more cars, but my ability to produce more cars has increased from point F to point A. Right, so by this we have reached the end of your session for the opportunity cost and PPF, and we'll see you next class.